What's up, team? Quick question before we start. Do you actually know migration, deployment, and IaC, CloudFormation, Migration Hub, DMs, Snow? By the end of this video, you will. Let's dive in. Your company just got the green light to move 300 servers and a dozen databases to Amazon Web Services, and you've got 6 weeks to do it. The budget's approved, so which tool do you actually touch first? Most teams reach for the wrong one, and that mistake quietly costs them weeks. By the end of this video, you'll be able to hear any migration scenario and instantly name the right Amazon Web Services tool, whether the job is inventorying servers, moving a database, shipping data physically, or codifying the new environment. The trick is realizing a migration isn't one big action, it's a pipeline of distinct jobs, each with its own service. Here's the mental model that makes every migration question easy. A migration runs in 5 phases, in order. First, you discover, you inventory what's actually running on premises. Second, you handle cost, you model the spend and build the business case. Third, you move the servers, lifting workloads into EC2. Fourth, you move the data, migrating the databases themselves. And fifth, you codify, capturing the new environment as code so it's repeatable. Hold on to those 5 phases, because every service we name in this video snaps into exactly one of them. 3 of these services sound almost identical and get mixed up constantly, so let's pin them down before we go further. Now that you know the move involves both servers and data, these will land. Application Migration Service, which Amazon Web Services abbreviates as MGN, is the lift and shift tool for servers. It replicates your source machines and relaunches them as EC2 instances. Database Migration Service, or DMS, is for databases. It moves them to Amazon Web Services while the source stays online, so CodeGorillas keeps that production database serving customers the whole time. And Elastic Disaster Recovery, abbreviated DRS, isn't a migration tool at all. It continuously replicates your servers so it can spin up recovery instances within minutes of a failure. Servers, data, disaster recovery. Keep those 3 straight and the rest of this video clicks into place. Let's make this concrete. CodeGorillas, a consultancy moving a startup onto Amazon Web Services, has just finished phase 1. They've inventoried every server in the source environment. So far, so good. Now comes the step most teams get wrong. They've got a production database that customers are actively hitting, and they need it on Amazon Web Services. Which tool actually moves it? Reach for the wrong one and you take hours of downtime nobody budgeted for. Reach for the right one and the source stays online the whole time. That single decision is what separates a smooth migration from a painful one, and it's exactly the kind of call we're learning to make. Let's start at the destination, the new environment you're building on Amazon Web Services. The old way of building it is clicking through the console, screen by screen. The problem is that no one remembers exactly what you clicked, and you can't repeat it reliably. Infrastructure as code flips that around. Instead of clicking, you describe your whole environment as a file, one you can version in Git, review in a pull request, and redeploy on demand. This is the principle Amazon Web Services calls operations as code, one of the operational excellence pillars of the well-architected framework, which is Amazon Web Services' official best practices model for cloud architecture. The native Amazon Web Services service for this is CloudFormation. You write a template that describes the resources you want, a bucket here, a database there, a load balancer in front, and CloudFormation provisions and manages them for you. Those templates are written in YAML or JSON, and the style is declarative, which means you describe the desired end state rather than the steps to get there. CloudFormation figures out the steps. The reason it matters so much is that it sits underneath nearly every other Amazon Web Services infrastructure as code tool. It's the engine they all run on. Now, writing those templates by hand in YAML, that's YAML, or JSON, that's JSON, can get verbose fast. A complex stack might run hundreds of lines. That's where the Cloud Development Kit, or CDK, comes in. On the left, CloudFormation is the underlying engine, declarative templates in YAML or JSON. On the right, CDK is a higher-level authoring layer where you define the same infrastructure in a real programming language. It supports TypeScript, JavaScript, Python, Java, C#, and Go. Here's the part that matters most. CDK is not a replacement for CloudFormation. When you run it, it synthesizes, it compiles down into a CloudFormation template, and CloudFormation does the actual deploying. Think of it this way: CloudFormation is the car's engine. CDK is the modern dashboard and steering wheel wired to that same engine. You can drive using the raw engine controls, that's handwriting YAML, or you can use the ergonomic interface of a programming language. Either way, it's the same engine doing the work underneath. So if you ever need to tell them apart, remember, CloudFormation is the engine, CDK is the friendly layer on top, and CloudFormation is not going anywhere. Before you move anything, 3 planning tools come into play, and they're easy to confuse, so let's separate them with a house move. On the left, Application Discovery Service is the surveyor, cataloging everything you own in the source environment. In the middle, Migration Evaluator is the accountant, pricing out what the move will cost. And on the right, Migration Hub is the project whiteboard, tracking which rooms are packed and shipped. 3 distinct jobs: inventory, cost, and tracking. Migration Evaluator is also used earlier in the migration journey for cloud economics planning. Here it sits in context with its 2 neighbors. Let's take the surveyor first. Application Discovery Service collects inventory, configuration, performance, and dependency data from your on-premises servers. It can do this 2 ways, with an agent installed on each server, or with an agentless collector that gathers the data without touching the machines individually. If a question asks which service discovers and catalogs your on-premises environment, this is the answer. One nice detail worth remembering: the service itself is free to use. You only pay for downstream storage of the data it collects, in places like S3. Now the accountant and the whiteboard. Migration Evaluator builds a data-driven business case and a total cost of ownership model for moving to Amazon Web Services, and it even factors in savings from reusing your existing licenses. So when a question is about justifying the migration financially, that's Migration Evaluator. Migration Hub is different. It's a single pane of glass that tracks migration status across all your different tools, and it also visualizes server dependencies. The key boundary to lock in: Migration Hub tracks and visualizes, it never actually performs a migration. This one trips people up, so let it sink in. Migration Hub monitors and visualizes progress. It does not move a single server or a single byte of data. A common wrong answer is to reach for Migration Hub when the scenario describes the actual move. The cue is simple. If the question says a single place to monitor migration status across tools, that's Hub. If it says move something, you need a different service, which is exactly where we're headed next. Now we get to the 2 services that actually do the moving, and the single most common mix-up on this topic. On the left, Application Migration Service, MGN, is your lift and shift tool for servers. It continuously replicates each source server block by block to a staging area, then launches them as EC2 instances with minimal downtime at cutover. This is the service that executes the rehost strategy, lifting a server as is and running it on EC2 without modification. On the right, Database Migration Service, DMS, moves databases. The source database stays fully operational while DMS replicates continuously until you're ready to cut over, and it handles both same engine and different engine migrations. The boundary to burn in: MGN is for servers, DMS is for databases. Here's an image to keep them apart. Imagine you're moving a restaurant. MGN moves the whole building and kitchen. The servers themselves, lifted and dropped into the new location. DMS carefully moves the recipe book and the ingredients, the database, without spilling anything, and it does that while the restaurant stays open for business. Servers, the building, database, the recipe book. If you remember nothing else from this section, remember that split. There's one more piece to the database story, and it turns on a single question. Are the source and target engines the same or different? Up top, we have a homogeneous migration, same engine on both sides, like Oracle moving to RDS for Oracle. The schema doesn't need to change, so DMS handles it alone. Down below, we have a heterogeneous migration, different engines, like SQL Server moving to Aurora PostgreSQL. Here the schema doesn't translate directly, so the Schema Conversion Tool, abbreviated SCT, converts the schema and stored procedures first, and then DMS moves the data, 2 steps instead of 1. Here's the decision rule, clean and simple. Different engines? You need SCT to convert the schema first, then DMS to move the data. Same engine, DMS alone, no conversion required. That single distinction, homogeneous versus heterogeneous, is the whole reason SCT exists. For example, if a company were moving an Oracle database to RDS on the same engine, DMS alone would suffice, but switch the target to Aurora PostgreSQL and SCT becomes part of the story. Amazon Web Services puts this plainly in their own documentation. The Database Migration Service frequently asked questions state that DMS supports homogeneous migrations, such as Oracle to Oracle, as well as heterogeneous migrations between different databases, such as Oracle to Amazon Aurora, and critically, the source database remains fully operational during the migration, minimizing downtime. That last part is the value of DMS in one sentence. You keep serving customers while the data moves. So far everything has moved over the network, but sometimes the network is the bottleneck. That's where the Snow family comes in. Ruggedized physical devices that Amazon Web Services ships to your site for offline bulk data transfer. You reach for these when uploading over your connection would take an impractical amount of time, like weeks or months. The workflow is straightforward. Amazon Web Services ships you a device, you copy your data onto it locally, you ship it back, and Amazon Web Services loads it into S3. The current lineup is the Snowball Edge, available in a storage-optimized model and a compute-optimized model. Snowball devices also serve a storage role, but in a migration context they solve a specific problem: too much data for the network. Think about moving an entire library's worth of books. You wouldn't read each page aloud over the phone to recreate them on the other end. That would take forever. You'd load them into an armored truck and drive them over. Snowball is that armored truck for data. When the internet connection is the slow phone line, you physically ship the bytes instead. The Q on a question is any phrase about too much data to send over the network in a reasonable amount of time. Here's the part that trips people up on recent questions. The Snow family just got smaller, and you need to know what changed. 2 devices were retired in 2024. Snowcone, the small one, was discontinued effective November 12, 2024. And Snowmobile? Yes, Amazon Web Services once had a literal 45-foot shipping container on an 18-wheeler that could haul up to 100 petabytes, was retired that same year. So what's left? Just the Snowball Edge storage optimized, with 210 terabytes of NVMe flash storage, and the compute-optimized model. According to Amazon Web Services, they trimmed the family because customers strongly prefer online migrations. One last thing worth memorizing: data transfer into S3 from a Snowball device is free. You pay for the device, but loading your data in costs nothing extra. We've covered the move itself. Now 2 services that stored on either side of it, one that governs what teams are allowed to deploy once they're on Amazon Web Services, and one that keeps production safe after the migration is done. The governance side is Service Catalog. It lets an organization publish curated catalogs of approved IT products that users can deploy themselves, on demand. Those products are often CloudFormation backed, with governance constraints baked right in. So instead of giving developers raw access to every Amazon Web Services service, you hand them a menu of pre-approved, compliant building blocks. The resilience side is Elastic Disaster Recovery, abbreviated DRS. This one provides continuous block-level replication for ongoing protection, and when disaster strikes, it launches full recovery instances in just minutes. Amazon Web Services defines it cleanly. The service catalog documentation says it enables organizations to create and manage catalogs of IT services that are approved for Amazon Web Services, and that end users can quickly deploy only the approved services they need, following the constraints set by your organization. Picture a corporate vending machine stocked only with IT-approved items. Employees grab what they need instantly, but they can only pick from what the organization pre-approved. That's governed self-service in one image. Now, DRS and MGN look almost identical under the hood. Both use block-level replication to a staging area, but their purpose is completely different. On the left, DRS is about ongoing protection. It keeps replicating continuously, gives you minute scale failover when disaster strikes, and you reroute user traffic yourself using Route 53. On the right, MGN is a one-time migration. Replication stops after cutover. It launches your servers as EC2 instances, and then you're done. It's built for rehost, not for standby protection. The discriminator, ongoing protection, means DRS, one-time move means MGN. Here's the image for DRS. Think of a stunt double standing by on set, continuously mirroring the lead actor's every move. The moment something goes wrong, the double steps in within minutes. No need to reshoot the whole scene. That's continuous replication plus fast failover. And remember the one thing DRS does not do: it launches your recovery instances, but it does not redirect your users. You handle that traffic switch yourself through Route 53. Remember Code Gorillas? 6 weeks to move that startup onto Amazon Web Services? Watch the whole pipeline fall into place. They discover with Application Discovery Service, justify the spend with Migration Evaluator, and watch it all through Migration Hub. Then they move servers through MGN, that real-time database through DMS, and a schema conversion with SCT if the engines differ. Too much data for the wire? Snowball Edge, with the load into S3 free. Finally, they codify with CloudFormation, or CDK if they'd rather write code, and lock down self-service with Service Catalog and protect it all with Elastic Disaster Recovery. And here's the one principle to carry out of this video. Every migration question is really asking which phase of the pipeline you're in. Answer that, and the right service names itself. Now let's see how well all of that stuck with a quick quiz. Question 1. A company is migrating an Oracle database to Amazon Aurora PostgreSQL. Which combination of services should they use? Is it A, DMS alone, since the source database stays operational? B, the Schema Conversion Tool to convert the schema, then DMS to move the data? C, Application Migration Service, since it handles all migrations to EC2? Or D, Migration Hub, since it coordinates the entire migration? Think about which constraint matters most here. This one is B. Oracle to Aurora PostgreSQL means two different engines, so it's a heterogeneous migration. The schema won't translate directly, so the Schema Conversion Tool converts it first, and then DMS moves the data. DMS alone would only work if both sides were the same engine. Question 2. A migration team needs a single dashboard to monitor the status of multiple workloads being migrated across several Amazon Web Services and partner tools. Which service fits? A, Amazon Web Services Migration Hub. B, Amazon Web Services Application Migration Service. C, Amazon Web Services Migration Evaluator. Or D, Amazon Web Services Application Discovery Service. Pause here if you want more time. The right call here is A, Migration Hub. The keyword is a single dashboard to monitor status across multiple tools. That's the single pane of glass. Just remember the boundary. Hub tracks and visualizes, but it never moves the workloads itself. Question 3. A developer wants to define Amazon Web Services infrastructure using TypeScript instead of writing raw templates by hand. Which statement is accurate? A. CDK replaces CloudFormation, which is now deprecated. B. CDK and CloudFormation are unrelated provisioning engines. C. CDK lets you author in TypeScript and synthesizes into a CloudFormation template. Or D. TypeScript cannot be used for Amazon Web Services infrastructure, only YAML or JSON works. Lock in your answer before I give it away. It has to be C, and here's why. CDK is the modern dashboard wired to the CloudFormation engine. You author in a language like TypeScript, and CDK synthesizes that down into a CloudFormation template, which does the actual deploying. CloudFormation isn't deprecated, and the two are very much related. Question 4. A media company has 400 terabytes of data at a remote site with a slow internet uplink and needs it in Amazon S3 as quickly as possible. What should they use? A. Upload directly to S3 over the existing connection. B. Amazon Web Services Snowmobile, the only device for this data volume. C. Amazon Web Services Storage Gateway to stream the data continuously. Or D. Amazon Web Services Snowball Edge to ship the data physically. Got your pick? Let's see. If you said D, well done. A slow uplink with hundreds of terabytes is the classic Snow family scenario. Ship the armored truck instead of crawling over the network. And watch the distractor. Snowmobile was retired in 2024, so it's not a current option. Snowball Edge is today's answer. Question 5. An enterprise wants ongoing protection for its production servers, with continuous replication and the ability to fail over to Amazon Web Services within minutes. Which service should they choose? A. Amazon Web Services Application Migration Service, since it replicates servers to Amazon Web Services. B. Amazon Web Services Elastic Disaster Recovery, for continuous replication and minute-scale failover. C. Amazon Web Services Backup, since it stores point-in-time recovery copies. Or D. Amazon Route 53, since it reroutes traffic during an outage. Run the decision rule from earlier before you answer. The answer is B. Elastic Disaster Recovery. The keyword is ongoing protection with continuous replication and minute-scale failover. That's the stunt double standing by. MGN looks similar, but it's a one-time migration that stops after cutover. And while Route 53 does handle the traffic reroute, it's only one piece. DRS is the disaster recovery service itself. That wraps up migration, deployment, and IaC, CloudFormation, Migration Hub, DMS, Snow. The Amazon Web Services. The Amazon Web Services Certified Cloud Practitioner Exam Mastery has more videos coming on the trickier topics. Subscribe so the algorithm tells you when. Thanks for watching.